Here now, figure 3 illustrates the limiting process that occurs in this example. As Q, the point Q here, approaches P along the parabola, the corresponding secant lines rotate about P and approach the tangent line. So the red is the tangent line, and we can see that Q, you can see here now it's getting closer to P, and then here it's getting closer to P, and it's approaching it from the right. And then from here you have a point Q that's on the left side, and it's approaching P from the left. So now let's take a look at Applet that illustrates this parabola and what happens with the secant line and how it meets the tangent line. So here, this is an applet, okay, and it says the slope of the secant line, and the function is here, f of x is equal to x squared. Here's the value of the initial x, and this is the change in x. Now, here we have the change in y, okay, and the change in y divided by the change in x becomes the slope. So the change in y, when you think about our slope formula, is y2 minus y1 over x2 minus x1. So since this is our slope, I want you to take a look at the line here that's in red. Okay, as we go down, you see the slope as it's going down the parabola here. And our slope is getting closer to what value? Well, it's going to 1, our slope is 1, now it's getting to what value? Well, right here, when it becomes horizontal, we get a slope of 0. So once it's completely horizontal, it's a slope of 0. And now if we move up and towards the left, you can see that the slope is now becoming negative. So the slope can change according to the line that is tangent to that curve. So as we rotate around, you can see the numbers that are changing because the slopes are changing. And that's kind of the idea of what we're looking at here, is the slope of the secant line.